better, maybe we can even obtain better results. That's true, but the idea is we are working.
Question to understand the results. Are you comparing one particular person against the rest, or from the whole bunch, random pick one and compare with the rest, and then another one and compare with the rest? You can always classify them correctly, or and you identify just one particular person?
In this particular case, we authenticate Albert between.
And you always running you against the rest, changing the
Certain samples of Albert between among the rest of the people.
So there's an assumption at the beginning. I want to now test if this is Albert.
Okay.
That's what.
So
they test if it is Albert.
There is the paradigm of the authentication process. We have, for instance, the mobile.
It's okay. I just
and
want
we
to
like
know
to see if you
the
are
rosters
the
of the system.
But it's not classification. It's not.
No.
Even in this case, who is the user?
No, by the moment.
This is
we are not trying to
authentication.
authentication.
Yeah,
I'm going to say if this is this, but this is it.
One question, but you have 11 people, and you have made the experiment combining only one against the other 10, like they
We
are
have done that with
forced.
everyone.
to
We have done it.
You should make at least for the 11. Just to be
Yes, we have done.
But I think
The results that is
the 3% is the average of the 11.
What is you? What is done that is.
But I think the problem is when you ask the people to work 10 times, 10 steps, I think most people work very similar, so it's very easy to find that one of the samples belong to the set. That is my assumption. But it's very easy if you put the 10 steps of the same person, they are very similar. So similar that it's very easy to classify at itself compared to the others. Because that's the problem you are solving. You have 10 instances of the Albert gate, and then you say, you take out one, and now I want to know if it's Albert or not. We compare to the other 9 with respect to the 200. And then you compare and say, oh, yes, it's Albert. But the question is, how similar it was already? Because if it's very similar, and you take 1 point, I don't know. I explained that very well.
You compare with each other, but also with the rest of the people.
Yeah, but if the rest is all over.
Not always. Here only are 2 people, but if you see with this picture with 11 people, sometimes are mixed.
Yeah, at least 3%. There's 3%, so it has to be mixed in some way. But to me, it's like the versicolor setosa problem. Like if the classes are very interconnected, that it's very hard to distinguish which class belongs. But if the classes are very separated, that it looks like they are very separated, it looks like it's very easy to know to which class belongs.
Where like that, we can recognize every gate. This is Albert, this is Albert, this is Albert, this is Albert. But in this picture, we have a mixed point. So recognize is more difficult than.
For instance, one experiment that I would like to maybe stronger and practical is that you have your mobile, your PDA with you, and you like. That experiment is already made with me, but still we have not the results. I think I take my work around the buildings here, and then I have this system, and probably I think because I am maybe changing, going down the stairs, maybe turning curves and so, maybe the system is going to have doubts about it is not glacial, but maybe 10 meters later it will check again. Okay, yes, it is. Is and so that is the experiment, because we can then check better if our system has a good level of recognition in different circumstances. I think that is a good check for go ahead with our system of human gate recognition, because at the end this is the target, this is the goal the system must have. And still we have not go in that.
Because here you say to one person, okay, you walk 10 steps. After you walk 10 steps, regularly, don't stop, don't do anything else. I recognize that these steps are similar to the other 10
we are
steps.
collecting pieces of a test that has 10 steps, 10 steps.
But what happens if you have tests with only 4 steps? You will be able to recognize the scheme. If you have 20 steps,
We have
So if
accepted
you
that 10
have-
steps is a good median, no? Because if we need more than 10 steps, we recognize.
no, the problem is
less.
if you always have 10 steps, it's introduce a regularity in the data.
No, because having 10 steps.
Always 10 steps introduce a lot of regularity in the data.
To get different amounts of data.
Different kind of walking of the same person. Different, now run, now walk,
we are
now
taking the
walk.
10 steps in, I think, no? Obtaining in a long sample, we extract 10 steps, sets
Yeah, just
of
the
10 steps
the
from
best
time
in
to
the
time.
middle. Because you don't want to have the beginning and the end.
No, okay, we eliminate the moment of starting, that is very strange, and the moment of stopping. We consider sets of the samples from in the regular working. That is also maybe we can set at the beginning. When you start on the chair and we start working, we are not going to recognize the human gait. That is normal.